Today we're going to learn about absolute value functions and graphs, and this is where we're going to apply what we learn about transformation, translations, all of our shifts and reflections that we learned about in 2.6. So I'm starting off with giving you the general equation. You can either see it like y equals or f of x, and if you notice, a, h, and k are back. So just to recap, A gives you your vertical stretch or compression. H shifts your graph horizontally. Remember, H is always opposite, so it'll either move left or right. And K always shifts your graph up or down. So that's a review from 2.6. And I'll write it just to remind you. So if A is greater than 1, that's a vertical stretch. If it's between 0 and 1, that's a vertical compression. And if you see the negative, I better write it out. And that's a reflection over the x-axis. H is a horizontal shift. And it's always opposite. And K is your vertical shift. K is not opposite, so it's true to whatever. If it's plus, you move up. Minus, you move down. Okay, and your book is going to tell you to make a table of values. We are not going to do that. I'm going to show you the quick way of graphing. And on all your graphs, this is very important, on all graphs, make sure you include the vertex, axis of symmetry, which we're going to abbreviate AOX, which is always x equals h. Your vertex will always be h, comma, k. And domain, and then you have range. Your domain is always negative infinity, positive infinity. And your range, and very important, all of our absolute values graphs are in the shape of a V, not a U. So make sure your graph is in the shape of a V. And then depending upon which way your V is pointing, if it's opening up, that means A is positive, then your range will be bracket K to infinity. But if your V is facing down, it's going to be negative infinity to K. So those will help you on all your graphs. So no matter what, every graph has to include all of those characteristics. So let's try the graph one. Okay, we'll start off with this graph, and we're going to use transformations. What we're going to actually do is start off with our basic our parent graph is what we call this. Y equals the absolute value of x. If you notice, we don't have an h or a k. So that means that our graph starts at 0, 0. And I'm going to graph the parent graph for the V, or the absolute value, which always starts off with these points: 1, 1, 2, 2, -1, 1, and -2, 2. Those are the points for the parent graph. And you will always start with those 5 points. And what we're going to do is we're going to use that to help us transform our graph. And just like on 2.6, we have to look at the equation to know where we're going to go. So according to our new equation, that -4 means that we're going to shift every point down 4. And it's best if you use graph paper on these because it makes the shifting easier. So here, here, here. And the reason why we use these points because the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of -1 is 1, the absolute value of -2 is 2. So here is your graph. And then you always want to label your characteristics. So we have our vertex, which is always H and K. H we don't have, so it's 0. K is -4. Make sure it matches what your graph is. Then we have the axis of symmetry. The axis of symmetry is the line that cuts your V in half and makes it symmetrical on both sides. And remember I said it's always X equals H. That's H, that's K. And make sure it matches your graph. The domain never changes for these graphs. And then your range is facing up. So if you notice, the lowest Y value is -4. And it's touching it, so it's a bracket. And it's going up. Those arrows mean to positive infinity. And that's your K value. So just to recap, axis symmetry, we always use your H. The range, we use the K. All right. Now, you try. I got it problem. I want you to graph y equals x plus 2. Now pause the video. Remember I got it, so we can. And we'll check our answers. And make sure you identify the 4 characteristics as well so you can practice. Okay, this particular problem, you notice I started off with my parent graph. And you don't have to actually graph out the parent graph. But it's there to help you when you're shifting. So the +2 is inside the absolute value, so that's a horizontal shift. And the only way it became plus is if H was negative. So that means that we're shifting our graph left 2 units. So the entire graph moved. And now my vertex is -2, 0. Remember, that's H and K. So in our equation, notice we don't have a K. Our axis of symmetry goes right down the middle. That's X equals -2. Remember, that's H. Our domain didn't change. And then our range is facing up. So we start with K, and we are going up to infinity. And there you have it. Okay, here's an example of a vertical compression. How did I know it's a compression? Because 1/2 is between 0 and 1. What that means is all of our y-coordinates, of our parent graph that we start with, will get compressed by 1/2. So I'm going to start off with my parent or my model graph. And what I'm going to do is take each y-coordinate and compress it by 1/2. This y-coordinate was at 2. 1/2 of 2 is 1. This one's at 1. 1/2 of 1 is 1/2. This one doesn't change because that's 0. This is 1/2, and this is 1/2. And if you notice, just think about it, we have compressed it and like smushed it and reduced it to 1/2 its size. So that's a vertical compression. And then I'm going to do vertex, which is H and K, and we don't have one. So it's 0, 0, and that matches my graph. My axis of symmetry, going right down the middle, is x equals 0. Remember, that's H and K. Domain, still the same. And then my range, it's facing up again. And my K value is 0. It's touching it, so it's always a bracket to infinity. And now, you can try our got it problem. But this time on your got it, I want to see if you're able to do if I put a negative in front. Alright, just try it and we'll see if you get it right. Okay, this is how the graph looks. I didn't do the characteristics because I want to go over these with you together. I mean, if you did it, that's wonderful. Okay, the negative. The negative reflects over the x-axis, which will make your V upside down. The 2 is still a vertical stretch, so all your y values got multiplied by 2. Now, very important. If you want to do it where you multiply the y coordinates by -2, that'll still give you the same answer. You can do that as well if you don't want to go step by step. But you don't have to show each transformation. You could just go from the original to the final graph. And so when you're doing your vertex, I still don't have an H and a K, so that's 0, 0. My axis of symmetry, remember I'm using H, it's x equals 0. And I'll label these again. My domain has not changed just because it's upside down, because domain, remember, is left or right. If you see these arrows, because that means that you can plug in anything you want for x with no restrictions. Now here's where everything is different with your range, because now it's facing down, and we always write our domain and range from left to right, or smallest to largest, or bottom to top. So if you notice, it's going from negative infinity, and our highest y value is 0, which is our k. And it's touching it, so it's always a bracket. So that's the difference when your absolute value graph is facing down, or your you have a reflection over the x-axis. Okay, we're going to try this graph, and it has — 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 1 4 transformations. So I start with my parent graph, and then I'm going to go left to right. So first I'm going to do the reflection. Try to do my points lightly. Then I'll do the vertical stretch of 2, or you can multiply the original ones by -2, whichever one works better. I'm going to try to erase as I go so we don't get confused. And then the -1 inside the absolute value means we move everything right 1. Sorry about the bell. So moving right 1, it would look like this. Right 1, right 1, right 1, right 1, and right 1. And then our final move would be everything shifted up 3. So I'm going to try to erase these extra dots. And there's our V graph. And then we'll do our vertex, which is H and K. And if you notice, even from our graph, you can see the H is 1 and K is 3. And then we have our axis of symmetry, which is X equals H, which is 1. So right down the middle. And then domain didn't change. And then my range. Be careful because it's facing down, so you got to start at negative infinity and go to your highest y value, which is 3, and it's a bracket because it is included. Okay, so now you try this guided problem. I want you to graph this one and try to do the characteristics, and then we'll go over it. Okay, so here's our final graph. I just want to go through the transformations with you. The first thing I did was did a vertical stretch of 3. So all my original y coordinates got multiplied by 3. And then I shifted the graph left 2, down 4. So all the points from the vertical stretch were moved left 2, down 4, which means, and if you notice, my vertex is now at -2, -4, which I'm showing in pink. My axis of symmetry is going straight down the middle at x equals -2. And just to reiterate, please write x equals on your axis of symmetry, or it will be marked incorrect. The domain doesn't change, and now my graph is facing up, and the lowest, the minimum y value is -4, which is our k, and it's going to positive infinity. So that's our absolute value graph. And remember, even if it says make a table, we're going to use the shortcut method of graphing. And that's it.